at Aston University, Birmingham. It's a pleasure to present my work, which is assessment framework for 3D concrete printing technology in alignment with Construction 5.0 criteria at this prestigious conference. Starting with the introduction of the study, as the construction industry is continuously evolving with the advancement of techniques and technologies, Construction 4.0 primarily focusing on automation and the integration of the advanced technologies like Internet of Things, artificial intelligence, digital twin, building information modeling, 3D concrete printing, robotics, etc. So Construction 4.0 has transformed the construction industry by enhancing automation, improving efficiencies, enabling the data-driven decision which improve the building processes. The main focus of this industry was on automation. That's why it doesn't give enough priority to the human-centric aspect of the construction industry. And in order to bridge this gap, a new industry, which is 5.0, marks a new paradigm where the focus shifts from solely automation to a human-centric approach. Unlike Construction 4.0, Construction 5.0 emphasizes the collaboration between humans and technology and ensuring that the worker will be the man or worker will be remain at the center of the process while using the technologies is a tool to enhance the construction capabilities. So what is 3D printing? Concrete technology is a construction technology that works by extruding materials layer by layer through a nozzle, creating a structure with minimal manual effort based on a digital model. So several studies have highlighted the alignment with Construction 5.0 goals individually like sustainability, resilience, human centricity, cost control, but a comprehensive framework for assessing its full integration is lacking. Also, 3D concrete printing offers key drivers such as material saving, reducing carbon footprint, enhance adaptability, and improve worker safety. So there is a limited research on identifying and evaluating the key drivers that enable 3D printed concrete technology to align with all the Construction 5.0 criteria. So there is a need for empirical validation to confirm its real-world application. So this research aims to fill that gap. The key objective of this study is to develop a framework to assess the alignment of 3D concrete printing technology with the Construction 5.0 criteria and to propose a conceptual implementation framework for 3D concrete printing technology and construction industry. The methodology used for this research comprises on 4 key steps. Number first, to conduct a comprehensive literature search which was conducted across a major academic databases such as Scopus, Web of Science, Google Scholar, which mainly focus on the peer-reviewed journal article, conference papers, and review article published since 2015. The keyword included to search the article was 3D concrete printing, Industry 4.0, Industry 5.0, construction, and digital construction. And the second step was for the methodology is identification of the Construction 5.0 criteria. So Construction 5.0 mainly focusing on integrating human centricity, sustainability, resilience, and cost and environmental control into the construction process. And the third step was the identification and conducting the content analysis of a key driver. For this purpose, 20 academic papers were thoroughly to identify the key drivers that enable the 3D concrete printing to meet the criteria of Construction 5.0. So the last step is the development and assessment and implementation framework based on the identified driver. In step 3, assessment and implementation framework were created. The assessment framework provides a structured methodology for evaluating the 3D concrete printing alignment with Construction 5.0 goal, focusing on the measurable impact of the key drivers. while the implementation framework outline a three-phase process. Number one is knowledge building, number two is adoption, and number three is performance assessment for integrating the 3D concrete printing technology into the construction industry. So now about the results is from the comprehensive literature search, we identified the four basic criteria for construction 5.0, which are human centricity, sustainability, resilience, cost, and environmental control. So for each of the criteria, we identified 10 drivers. So each driver was assigned a unique code C is shown in the table to facilitate the clear and structured representation throughout the analysis. And then the frequency of each driver occurrence in the literature was calculated using equation F is equal to summation of driver occurrence in the article in the literature to quantify its prominence. After that, the significance S of each driver was assessed based on its frequency in the literature and categorized as high, medium, or low. After that, we assign a qualitative score, was then assigned 5 for high, 3 for medium, and 1 for low to quantify its relative importance for further analysis. And then each driver are ranked based on the literature score derived by content analysis, in which the influence of each driver, high, that is medium, low, is determined through examination of the literature score. To determine the literature score, we use the formula of QS multiplied by F divided by A into N. So where A is the highest possible qualitative score, N is the total number of papers which were considered for the identification of the drivers. So on, the normalized literature score is calculated by dividing the each driver literature scores by the total literature score, ensuring the relevant data is considered and remove the redundancy or repetition. After that, we calculate the cumulative score to provide the aggregated measure of the importance, and these all are shown in the table. Like human-centric criteria, we identified the 10 drivers for that. We also similarly, we identified the 10 drivers for the sustainability criteria. And we perform a similar kind of the analysis where C represent the code, F represent the frequency, S represent the significance, Q represent the qualitative score, L S represent the literature score, L and S represent the literature normalized score, and CS represent the community score, and then RAN. A similar kind of analysis was carried out for the sustainability criteria as we carried out for the human-centric criteria. Again, similar as we identified the four main core criteria for the construction 5.0. So this is the third criteria, resilience drivers. 10 drivers are identified for the resilience driver 2 in order to align the 3D printed concrete technology with the construction 5.0 criteria. So a similar kind of analysis was performed as we performed for the previous two criteria. This is the last criteria for construction 5.0, which is reduce cost and environmental control. 10 key drivers were identified for this criteria, and a similar kind of analysis was performed as we performed for the previously three core criteria of the construction 5.0. This is the assessment framework, which the alignment of 3D concrete printing with the construction 5.0 is evaluated based on four key criteria, which are human centricity, sustainability, resilience, and cost and environmental control is shown in this framework. And each of these criteria represent a core goal of construction 5.0, and for 3D concrete printing to be fully aligned, it must meet specific criteria with each of these criteria. By identifying these key drivers under each criteria, we are able to assess how 3D concrete printing can support the goals of Construction 5.0. This framework provides a structured way to evaluate how 3D concrete printing technology meets the specific requirement of human centricity, sustainability, resilience, and cost and environmental control, and help to prioritize these drivers based on their significance and impact on the construction processes. The implementation of 3D concrete printing is designed to guide the practical application of 3D concrete printing within the construction industry and ensuring it's aligned with the Construction 5.0 goals. And this framework consists of three main phases, which is knowledge building, adoption, and performance assessment. So the knowledge building phase mainly focusing on raising the awareness and building understanding of 3D concrete printing technology with the construction industry. This mainly involve collaborating with the academic institution, industry bodies, and professional organizations to integrate 3D concrete printing technology into the training programs and education curriculum. The goal is to equip the stakeholder with the necessary skill and knowledge through case studies and real-world examples, ensuring that the industry is prepared for the transition to 3D printed concrete technology. The second step is the adoption, which mainly focusing on overcoming the initial barriers to the widespread implementation of 3D printing technology in the construction industry. Key action included that to provide the financial incentives such as subsidies, taxes exemption to reduce the high initial and upfront cost of associated with the 3D printed technology. Additionally, engaging industrial stakeholders to develop implementing strategies, standards, and guidelines help ensure the consistent and effective use of 3D concrete printing technologies. So adoption phase ensures that the technology is successfully integrated into the industry by addressing the financial and technical challenges. Mm. And the third phase is the performance assessment, which is the final phase and focusing on the ongoing evaluation and optimization of 3D concrete printing technology, which involves setting up a monitoring system to track the performance of 3D printing technology in real time, measuring its impact on the key construction 5.0 goals like sustainability, resilience, cost efficiency, and also a feedback loops are established to ensure the continuous improvement, allowing the technology to evolve and remain aligned with the needs of the construction industry and construction 5.0 principles. The main conclusion from this study is that the 3D printing concrete technology hold a very strong potential to drive the shift of towards the construction 5.0, and one of the key technology for the construction 5.0, and the other is to the provided framework offer both the method for the assessment and a guide for the implementation, supporting the industry in this important transition from construction 4.0 to the construction 5.0. This research opened a new way for a researcher uh, to integrate a gray literature with empirical data, that is surveys and case studies to enhance the framework validation. Also, they can verify this validation to implement in a construction industry, and also the framework can be applied to the various 3D concrete printing construction scenarios to assess its adaptability and industrial impact, and also researchers can validate it through creating a system dynamic model for that. These are the list of the references which we use for preparing the presentation. Thank you so much for your attention, and I will be happy to answer any questions you may have during the question and answer sessions.